to the next video, video number 3. Linear or not linear? Linear if it has a constant rate of change. And it's a straight line, remember? So in other words, my slope, or the rate of change, which is change in y over change in x, or difference in y over difference in x. If these differences have the same ratio for all of the points, then it is a linear function. So I'm going to start by doing the differences over here. Oh, this is minus 4, minus 4, minus 4. So it looks like the differences are the same. When I do my change in y over my change in x, all of them are going to be negative 4 over 5, negative 4 over 5. Already simplified. So this is linear. All the same rate. I'm going to do the same thing over here. It's plus 2, plus 2, plus 2. Okay? Over here is going to be plus 2, plus 4, plus 10. Difference in y's over difference in x's is going to be 2 over 2, 4 over 2, and 10 over 2. Okay? This is 1, this is 2, this is 5. These are not the same, so this would be not linear. Okay? So if the ratios of the differences are not the same, not linear. Remember the Terra problem where it was 15 miles or 15 cents per mile plus a $45 charge, and we all had different points, and I showed you the ratios of both, and then all of them gave me 15 cents because it was a constant rate of change. Alright, so here student council is ordering customized foam hands to promote school spirit. This is a table, number of hands, and the cost in dollars for each. We need to know if this can be a linear situation, and we have to explain. And if it is, we need to write the linear model. When you see linear model, they mean the equation. Okay? So let's see. And then here, remember that as a function of number. So this is the x, and this is the y. And you already knew that from here. X and y. Okay? So first we need to know if this is linear or not. So this would be plus 2, plus 2, plus 2, plus 2. This one would be plus 12. Okay, this is also plus 12. Plus 12, plus 12. So if I do the change in y over change in x, in all of them I would have 12 over 2. 12 over 2, 12 over 2, 12 over 2, 12 over 2. Sometimes you get a different ratio and you think that it's wrong. Remember that the problem with the chambers that we guessed first, that none of them were, only one of them is linear and all of them turned out to be linear? Because when we simplify the ratio, like it gave you the same thing. So if you have different numbers here and here, make sure you simplify it. And if you get the same thing, you still have a linear equation. All of these equal to 6. So yes, this is linear. Because there is a constant rate of change of $6 per hand, or from hand. Okay? Dollars hand. Okay? So it is linear. Now I want us to do the equation. So I'll do my 3-table equation. I already know what the slope is. I just need 2 points. I'll just choose the first one, 434 and 646. I already know my slope is 6. I don't have to redo it. I just did it up here, right? Changing y over changing x. Now I just need to try it to see if I'm missing something. 6 times 4 is 24. 24 plus what would give me 34? Oh, plus 10. Now let me to see if it also is the same. 6 times 6 is 36. Is 36 plus 10 46? Yes. So now I know that I missed, and this is my function, and my equation. Y equals 6x plus 10. Okay? Alright, for these, we need to find a graph that best represents the situation. Amy ran to the library, so we're talking distance and time. So if she ran to the library, studied for a while, then walked home. Okay, so from when she says study for a while, this is going to be a flat line because the distance is not going anywhere because she's at the library and not moving. And then she walks. So here my two keywords ran, that means it's going to be like a faster incline or an inclined more, and then walked means it's slower pace, and I need a little flat in the middle. Okay, so it looks like it could be, we need this distance from home. Okay, she ran to the library, studied, and then walked home. The only thing that doesn't make any difference is this space of time right here looks like it's slower, going steadily slower than this pace over here. So this one's kind of backwards. So this wouldn't work. I need something that's like this but backwards. This one, it looks like for this amount of time, her distance increased rapidly. Then she stayed there, and then this one's going up but like slowly. It's because she's walking home. So it looks like B is the answer. For number 8, Mr. Jones is filling his pool with water. So here's the gallons. We start at 0, 0. They all start at 0, 0, so that's good. Okay, and then versus time. Jones began filling the pool at a constant rate. So that means like it's increasing steadily. It looks like all of them are doing that in the first period of time, so we can't cancel any. He turned off the water for a while. So the water is not going up, the gallons are not increasing or decreasing, they're staying flat for a while. Okay, so it looks like I have a flat line here, flat line, only a little bit of a flat line, and a flat line. So all of them have a little bit of time where it's not changing. He then turned the water back on at a slower constant rate. So this one would be faster than that one after the break. Okay, this looks like it's going up faster, so letter C, no. This one also looks like it's going faster than that, so no. This one looks slower, that one looks slower. So far, these two. Mr. Jones turned off the water again for a while, so now we need another flat line. So we do have a flat line here after, we have a flat line there after. So it's true. Okay, and then we can't even see what this is. I think it says he turned it back on the first rate. So it needs to look like the first line. And we can't really tell from these. Yes, he turned it back on the first rate. So it's going to look like this one. This one looks like that one, right? This one's going like this. This one looks like it's going to go back up that way. This one goes down. He doesn't empty the pool, so not this one, so it's going to be A. This one's a little weird because we can't see the last one. Sorry about that. Which of the graphs best shows the average height of people from birth to age 50? So definitely height doesn't decrease that much. You're not born tall and then your height decreases. So probably not A. Okay. This one, it says it slowly increases, or fast increase, and then it kind of stays the same for a while. This one says you keep growing. I mean, at a certain point over here somewhere, when you're like 18 or 20, you stop growing. So you don't keep growing forever and ever. So this is not true. So it's either that one or that one. This one has a very slow change in height until you're like 40 or something, and then you finally go increase in height like rapidly at age 50. That doesn't make sense. This one, you kind of gradually but at a fast rate grow, and then it cuts off like an early age, like 18 or 20, and then you just kind of stay the same. So that one makes more sense. Lori's riding her bicycle on a circular track. Terry's standing in the center, this should be an E, of the track. Which graph shows the distance between Lori and Terry to the time since Lori started riding? Shows that the distance, this should be relates. I'm sorry, I didn't write these and I should have proofread them before. So here's, Terry is at the center of the track, and the track is kind of over like this, and here is Lori. Okay? So here's distance between Lori and Terry and the time. So when she's moving around, like in the clock, the distance is going to kind of be far away, and it's going to keep getting closer. When Lori is here or here, she's going to be closer to Terry than at any other point. So it's like far away and then getting closer until they're close, and then far away again until they're close again. Okay? So it's going to be far and then slowly getting close, and then far again and slowly getting close. This line looks like they're always at the same distance throughout the whole time, which you know it's not going to be true. This one says at the time they start super close, and then as she runs, she keeps getting away and away and away and away from Terry, which is not true because Terry's at the center, so not that one. Okay, this one says that there's no distance in between them, then the distance grows. Okay, once it gets to like far away, it decreases, and then they're like super close to each other, or next to each other, no distance in between them. Then again, far away, then no distance. Over here, it says that when they start, they're like together, and then their distance is going to increase between them, and then decrease until they're together again. Okay? So for me, this one makes more sense, even though they're like not together. This should not be 0. None of these should be 0. It should start somewhere over here, like this. Okay, because they start close to each other, and then they go far away, and then close, and then far away, and then close, far away, and then close. So close, far away, close, far away, close, far away. So letter C makes more sense. Okay, the back, you have to do the x and y intercepts. To find the x-intercept, I'm going to make y 0. So I can eliminate it. So the x-intercept is negative 14 over 4, negative 15 over 4. I cannot simplify that, so negative 15 over 4, comma 0. The y-intercept, I have to make x be 0, so I can solve for y. Y-intercept, solve for y. X-intercept, solve for x. So here, I have 5y equals negative 15. Y equals negative 3. So if I was a coordinated point, I made x be 0 and y is negative 3. Okay? Over here, I need to find f of 7 plus 9 times g of negative 1. So first I need to know what f of 7 is and what g of negative 1 is. And I have a graph to figure that out. This one, the solid line, is the f of x. So when x is 7, which is right here, this one, f of x, is negative 1. So this is a negative 1. G of 1. When when x is negative 1, I'll go over here, here's negative 1. Where is the g? G is the dotted line. So I go up, and it looks like it's positive 1, right here, negative 1, positive 1. Okay? So then I have negative 1 plus 9 times 1 is 9. That's going to equal 8. Alright? now it's the same thing. The last part, we're just going to evaluate. G of 10, I think we did that, something similar in class. I wrote the original. I'm going to substitute for the 10, for the x, I'm sorry, and I'm going to substitute 10 in. So instead of x, I have 10. So G of 10 equals 40. Now it's f of x. Instead of x, now I'm going to substitute it for negative 2. So that will be negative 4 minus 1. F of negative 2 equals negative 5. Okay? Here I have to subtract these two, but I have to evaluate them first. F of 3 is, I'm using the original equation, I'm substituting the x for the 3. 2 times 3 minus 1. G of 7 would be 4 times 7. So F of 3 is 5. G of 7 is 28. So now I have to do 5 minus 28, and it equals negative 23. Negative f of 2x. So first I need to know what f of 2x is. Okay, so I'm going to do f of 2x first, and then I'll do the negative. So instead of x, I need 2x. So it's going to be 2, right? Instead of x, I'm going to put 2x. So 4x minus 1 is this piece right here. And now I have to do the opposite signs to it, or make it a negative. Negative 4x minus 1. And now all I have to do now is make it that negative sign here. Okay? And then I have to bring in the negative inside the parentheses. Remember I told you there's a negative in front of something, all it does is change each sign to the opposite, okay? So that would be the answer. Here I also have more things, right? 2 times g of x plus 4. I need to do this part first. G of x is 4 times x. If I want g of x plus 4, I'm going to substitute the x, right, for for x plus 4. So g of x plus 4 would be 4x plus 16. Now what I have to do with it is multiply it by 2. So now I need this part right here. So 2 times whatever that g of x plus 4 was, which is this. Now I have to distribute one more time. So this would be my answer. Okay? Over here also, I need to first know what this part is first. So g of x, the original, is 4x. Instead of the x, I need to sub it by 3x, right? So g of 3x. So instead of the x, I have 3x. Instead of the x, I have 3x. I'm going to substitute it. That would be 12x. So this whole part is 12x. All of that. Now I need to square it. 12x squared. Okay? That means 12 times 12 and x times x. Okay? So that would be my answer. 12 squared is 144. That means 12 times 12. X times x is x squared. All right, and that concludes your review.